All right, assignment 5.5. So this whole lesson had to do with integrating, being the antiderivative. So we're going to be working backwards. And so we're practicing how to integrate. And this one had to do with the anti-power rule and U substitution. So let's do it. So number one I wrote down. So I want to integrate this using the anti-power rule. And that involves understanding there's a hook involved. So if I take the derivative of the base, it equals what's here outside. So the derivative of this base is 3. I have the hook that I need. So what I do is this. When I do the antiderivative, I get rid of the hook, and then I add 1 to the exponent and divide by that exponent, and then I don't forget the constant or the candy. So for the anti-power rule, I need to set up the hook properly, and once the hook is set up, when I integrate, I get rid of the hook and then add 1 to the exponent and divide, working backwards. Let's try it again. Number 2. Integrate 5t, subtract 3 to the 8. So let's start. I want to know what the hook would be here if I took the derivative. So what's the derivative of the base? So the derivative of 5t subtract 3 is 5. Now there wasn't a 5 there before. So what I do is I undo the hook outside. So what was the number before and divide it by what it became. So before there was a 1 there and it became a 5. That's the fraction that undoes it. So if I multiplied them together, it would be what it was before. I circle the hook and get rid of it. And then my answer is going to have 1/5. And then we do the anti-power rule, which is we add 1 to the exponent and divide. And then don't forget the constant at the end. Done. Number 3. Again, I'm going to write this, but I'm going to write this calculus friendly. So I have x squared, but I'm going to write 4 subtract x cubed to the exponent negative 1/2. So right away, I write it in a calculus friendly way so I can do calculus rules to be able to integrate antiderivative. What is the derivative of this base? And the derivative of 4 is 0. And the derivative of negative x cubed is negative 3x squared. So I'm going to write negative 3x squared. That's the hook that I need. So I write down the hook that I need. It wasn't there before. That's the hook that I need. So I need a fraction to keep it the same question. So what is the fraction in front? And what was the number before? Positive 1. What did it become? Negative 3. And that's the number that needs to be a part of the integration. So if I multiplied them together, it would stay the same question. But this one has the correct hook. Circle the hook. Hook be gone. The question, the answer is going to start with negative 1/3 times. And then we do the anti-power rule. So we multiply, or we add 1, I'm sorry. So negative 1 plus 2. We add 1. That's positive 1/2. Then you divide or times the reciprocal. And don't forget the candy. And yes, you could write this as negative 2/3. Now, if I took the derivative of this, it would equal this where it was before. So they match each other. One's the integration, one's the derivative. Number 4. And number 4, again, I'm going to write it calculus friendly. So it's going to be y squared subtract 3 to the exponent 1/2 dy. Oh, and there's a y there. I'm just going to put that y in front instead of behind. So there's a sneaky little y at the end. I'm going to put it in front. So there it is in front. So first, what is the hook that I need? So what's the derivative of this base? And it's 2y. That's the hook that I need to do the antiderivative. And then what fraction do I need so it stays the same? So what was it before? 1. And then what did it become? 2 is the hook I needed there. Then I can circle the hook and it goes away. And the answer starts with 1/2. I add 1, so it's 3/2. And then divide or times the reciprocal. Don't forget the constant. Yes, the 2's divide out, so yes, you could write it as 1/3 if you wanted to, but you don't have to. And it's done. Number 5. Again, I'm going to write this calculus friendly. So I see a fraction, so I want to write it better. So I'm going to write it as x cubed plus 2 to the exponent -6. And then I'm going to write it over again. But this time, what's the derivative of just the base? That creates the hook. So that's 3x squared. What was it before? 5. What did it become? 3. Circle the hook. It goes away. So our answer is 5/3 times x cubed plus 2. Add 1 to the exponent and divide. Yes, you could simplify this if you had to. So the 5's divide. That gives you -1/3. X cubed plus 2 to the -5 plus c. Number 6. At some time, you should press pause and try it first yourself. So the first thing I notice is I want to write it calculus friendly. Do you have that skill? So notice it becomes to the -1/2. Next, what's the derivative of the base? It's -1. That's what needs to be in front. That's the hook. What was it before? What did it become? So use that as a way to know what number should be in front. What it was before over what it became. Then when you multiply it together, you'll get the same answer. Circle the hook, it goes away. So that's a negative divided by negative. That's +3. Add 1. So -1 plus 2 is +1/2. Divide or times the reciprocal and then the constant. And that's it. That's a great answer. Number 7. So number 7, I have 2x squared minus 3x to the 4th and 4x subtract 3 dx. So I take the expression with the bigger exponent and the hook is the one beside it. So what's the derivative of this base? And it's 4x subtract 3. That is the hook. I don't need to change anything. It's what it should be. So circle the hook, it goes away. And then we add 1 to the exponent and divide, and then the constant. And that's it. So when everything fits in place, it can be very simple. Just add 1 to the exponent, divide, don't forget the constant, and it's over. Number 8. Again, I'm going to write this calculus friendly right away. So as soon as I see a fraction, I write it with a negative exponent. So that's 2x squared subtract 4x to the exponent -5 dx. How do I factor this? So the first thing I look at is the expression with the bigger or smaller exponent And so understand u and understand u prime when I do this. So the derivative of u prime, this is what it needs to become. So in order for this to work, what is the derivative of u? What is u prime? What should it be? The hook. So it's 4x subtract 4. Now, what was it before and what did it become? What's the difference between it? Well, to see that, what was there before is that you might have to factor it to see it. So can you factor out a 4 in front? And maybe you'll see it then if you factor it to see what was the number before and what did it become. So if you factor out a 4 in front, you could see what it was before was 1 and what it became was a 4. So a constant you can manipulate. Then circle the entire hook and it goes away. 1/4 is part of your answer. And then add 1 to the exponent. So -5 plus 1 is -4 and divide by -4. And then don't forget the constant. These 4's don't cross out. They would actually make -16 because they're both in the denominator. Number 9. I don't need to write that down. All right, number 9, again, we're going to write calculus friendly here. So I'm going to write it as t to the exponent 1/2 minus 4 to the 10. And then in the denominator, I'm going to write that as t to the -1/2. So this is what it looks like. So t to the -1/2, t to the 1/2 subtract 4 to the 10. This is obviously u, this is u prime. So if I take the derivative of u, the hook I need is 1/2 t to the -1/2 That's the hook I need. The derivative of the base is there. What's the difference between them? Well, there was a 1 and then it became 1/2. So it's 1 divided by 1/2. So if I put that together, that's actually 2. 1 divided by 1/2 is 2. Then circle the whole hook, it goes away. And then it's the anti-power rule, which is you add 1 and then divide, and that's it. Number 10. All right, let's look at number 10. Again, I'm going to write it calculus friendly. So that's going to be 5x to the exponent -1/3. So the hook here, the derivative of 5x is 5, what it was over what it became. So the hook of 5 goes away. So my answer is 1/5. And then you add 1. So -1 plus 3 is positive 2/3. Divide by 2/3 or times the reciprocal. And then the constant. And yes, you could write that as 3/10. Number 11. (2u plus 1 squared du). So one way to do this is to FOIL it out. And the way we're learning today is you find the hook. The derivative of this is 2. What it was over what it became, so it needs a 1/2. The hook goes away, so our answer is 1/2 tu plus 1, add 1 to the exponent and divide, and then the constant. I think this is easier than foiling and doing the other part, but it's up to you. It's good to know this technique. This is what we're practicing. Number 12. So y cubed, and then I have y minus, now 1 over y I'm going to write as y to the negative 1 dy. Now for this one, this is not u and u prime. They're not matching. I'm actually going to distribute. So I'm going to do some algebra. So y cubed times y, add the exponents, and you have y to the 4th. Same thing here, subtract, distribute, add the exponents because the bases are the same. That's y squared. And now it doesn't need anything very tricky. Now it's just each one the anti-power rule. So add 1 and divide, add 1 and divide, and it's over. So sometimes algebra can make things easier if you see the algebra. Number 13. Here's another algebra question that then turns into calculus. So can you simplify and see the algebra to simplify here? And the indicator to me is the monomial on the bottom. So with a monomial, you could write it as 2 fractions and then integrate each one separately. So this is the integration of 1. This is the integration of 3x to the negative 2. Each one should be dx for each integration sign. And that's it. Integrate it. So the integration of 1 is x. The integration of this is you add 1 to the exponent and divide, and then the constant. And you don't have to simplify it. If you did want to, a negative divided by negative is plus 3. X to the negative 1 is really over x. So in multiple choice, you'd likely see something that looks like that. Number 14. Last one to practice like this. So look at number 14. So again, the indicator for number 14 is the monomial in the denominator. So see the monomial root x? I'm going to change that to x to the 1/2. So we have 3x squared plus x minus 2. I'm going to change that to x to the 1/2. And then I'm going to write it as 3 separate fractions, all using x to the 1/2 as a denominator. So I have x squared over x to the 1/2 dx. I integrate again, x over x to the 1/2 dx. And I integrate again, 2 over x to the 1/2 dx. So I have each one, and I separate it into 3 different fractions. And then I just do exponent rules. So subtract the exponents, and 2 take away 1/2 is 1.5, or 3 over 2. That's a 1 that you don't see. 1 take away 1/2 is 1/2. And then the last one, there's nothing to simplify it, but we're just going to write it as x to the negative 1/2. And now I did some algebra where each one now I can just integrate separately. Yes, dx, dx, dx. All right, so now it's just the anti-power rule. So we write down 3x, add 1 to the exponent. That's 5 over 2. Divide or times the reciprocal. Let's do it again. Add 1, so 1 plus 2 is 3 over 2. Divide or times the reciprocal. One more time. Add 1, that's positive 1/2. And again, times the reciprocal. So instead of dividing by 1/2, that is 2, and then the constant. So if you wanted to make this a little bit nicer, that would be 6 over 5, x to the 5 over 2, 2/3, x to the 3 over 2, minus 4, x to the 1/2, plus the constant. Done. All right, so that was practicing integration. The next we need to practice is U substitution, which is a lot lengthier and a little bit more complicated. So let's take our time to practice U substitution here. So we're going to integrate 2x and the square root of x plus 1 dx. So how am I going to approach it? Why can't I do what I did before? So let's talk about that. So first of all, the square root of x plus 1 is x plus 1 to the exponent 1/2. That allows us to do calculus rules. If I took the derivative of x plus 1, it would be unlike the term in front. They have to be like terms. When I do the hook I have already, they have to be like terms or else it doesn't work. So in other words, if the degrees match here, I'm going to have a different way to do it. So for U substitution, I'm going to let U equal x plus 1. What's underneath the square root sign, or to the exponent 1/2. I'm going to solve for x. So to get x by itself, I'm going to subtract 1. So x is equal to U subtract 1. I'm going to take the derivative of x. So the derivative of U is du, and the derivative of negative 1 is 0. So I'm going to use these and plug them in here. So where there's x, I'm going to put in U minus 1. So x equals U minus 1. That's x right there. X plus 1 is U. And dx is du. So now we have no more x's. It's only u's. But we've done something where I can now actually do the antiderivative. Now I'm going to do some algebra first. So this is 2u minus 2, u to the 1/2. Still going to do more algebra. I'm going to distribute. So it becomes, you add the exponents. So when you multiply them together, it's 1 plus 1/2. So that's 3 over 2. Same thing here. I'm going to multiply these together. So it's negative 2, u to the 1/2. And now I just do the anti-chain rule. So that means I'm going to add 1. So that's 5 over 2. Now instead of dividing, I'm going to go times the reciprocal. I'm going to do that here too. I'm going to add 1, so that's 3 over 2. Divide or times the reciprocal, and then the constant. So you've done the antiderivative. 2 times 2 is 4 over 5. Now you plug in what u equals at the end to get your answer. So u is x plus 1. So take out the u and put in x plus 1. Take out the u, put in x plus 1. And using U substitution, you've done the antiderivative there. So that just takes a little bit of practice. All right, number 16. All right, I think we're going to go to like 17. Let's see. 16. We'll see how far we'll go in this video. So 16, the integration of 5 minus 4x, and then we have 2x subtract 1 to the exponent negative 1/2. So I'm still going to write it calculus friendly. So instead of a fraction, instead of a radical, be able to write it with a negative fractional exponent. Notice that if I take the derivative, so if this is u and u prime, I couldn't do it, because they are on the degrees match, and when I take the derivative, they won't be like terms. So now what do? So let u equal 2x subtract 1. Solve for x. So I'm going to add 1 and then divide everything by 2. So I need this, and then take the derivative. So the derivative of x, so this is 1/2 the derivative of u, and the derivative of 1/2 is 0. So this is what I need when I substitute back in. So one step at a time, take out the x, and it becomes u over 2 plus 1/2. Take out 2x subtract 1, and it's u. Take out dx, and it becomes 1/2 du. Now I'm going to tell you that 1/2 du, the 1/2 could actually go in front, if you like. So that's one of the properties of integration, is that scalar multiple, that 1/2 could go in front of the integration sign. And then at the end, we'll tack on that at the end for the answer. All right, I have some cleaning up to do here. So first step is inside that first parentheses. I'm going to distribute. So 2 goes into 4 twice, so that's minus 2u. And half of negative 4 is negative 2. So that's nice. The next thing I'm going to do is combine like terms inside. So 5 take away 2 is 3 minus 2u. The next thing I'm going to do is distribute and use exponent rules. So I still haven't done any calculus here yet. So 3 times this is just 3u to the negative 1/2. Multiply them together, it's negative 2u, and you add the exponent. So 1 plus negative 1/2 is positive 1/2. So we're just working with algebra to a point where I can then do the antiderivative. So for the antiderivative here, you're going to add 1, that's positive 1/2, divide or times the reciprocal. Same thing here, you're going to add 1, that's 3 over 2, divide or times the reciprocal, and then the constant. So simplify what you can. So we have 1/2, we have 6u to the 1/2, and then if I multiply this together, I got 4/3 u to the 3/2, plus the constant at the end. Distribute the half and you get 3. Now instead of u, I'm going to put in what u is again, which is 2x subtract 1. Again, 1/2 times 4/3. 2 goes into 4 twice, so it's 2/3. 2x subtract 1 to the 3/2, and then the constant. So at the very end, take out and remember what u equals. So put in 2x subtract 1, and you've now done integration by U substitution. All right, one more like that, 17. So for 17, we have 3 subtract x and 1 subtract x to the 1/2. All right, let's see if we can do this together. So notice I already put it to a fractional exponent. Again, the degrees match. So I have to do U substitution. So U is going to be 1 minus x. If I add x and subtract u, x is equal to 1 minus u. I just added x and subtracted u. That means dx is negative 1 du. So the derivative of 1 is 0, but the derivative of negative u is negative du. So now I'm going to come back here, take out the x and put in 1 minus u. Use parentheses so you don't make a mistake. 1 subtract x is u to the 1/2, and then dx is negative du. So I'm just going to put that negative in front. Now I got some algebra to do. So 3 subtract 1 is 2, and a negative makes it plus u. Distribute, use the exponent rules. So that becomes 2u to the 1/2. And then notice that there's an exponent 1, so you add the exponent, so it's 3 over 2. Now we can finally do the calculus. So we add 1, so that's 3 over 2 times the reciprocal. Same thing here. Add 1.